Welcome everybody to this lecture which is presented to you by the Institute of Engineering and Technology. Welcome to those of you who travelled to Solent to be in the room with us, and welcome to those of you watching the live stream. But for those watching online, the video will be available on demand in due course. My name is Rupert Brunn. I'm a media consultant and a member of the IET Media Executive Committee, which sounds very grand, but basically it means we just try to organise events like this one for people in the industry to learn and enjoy. And tonight we are very pleased to have a lecture on the subject of live sport and entertainment immersive mixing using machine learning. It's going to be given to us by Rob Oldfield. Rob has worked in the audio and broadcast industry for over 17 years and gained his PhD from the University of Salford in object-based immersive audio in 2013. He's passionate about innovation, about sport and broadcast. He's co-founder of Salsa Sound, who have developed a patented AI engine which automates and enhances audio mixing for live sports broadcast. They say that it improves mix quality, consistency and production efficiency, and he's going to explain to us just how it does that. Rob's interest in sport doesn't just extend to using clever software to provide great audio though. He's a very keen runner, and it's rumoured that he once submitted and presented a paper at AES in New York purely because he managed to get a place on the New York Marathon.
May or may not be true.
He's also a percussion player in a ceilidh band, so obviously a man of many, many talents. So I hand over with great pleasure to Rob.
Thanks, Rupert, and thanks for having me. It's good to be here. And turns out Solent University is great. Just had a bit of a tour and fantastic facilities, and it's good to see like real-world TV production being taught with real-world facilities. So I'm excited about that, and it's good to be here talking to you about. I changed the title around a little bit because I think it sort of reads nicer. Immersive mixing for live sports and entertainment using machine learning. So going to talk a little bit about kind of how live sports produced in general, and look at some kind of new workflows that can be leveraged using AI and some immersive bits and pieces in there. There's lots of slides, and I'll rifle through some of them, and then because we're sort of in the round, like maybe it will sort of bring it together and we can have a bit of a discussion and some questions, and just maybe kind of chew the fat together on where the industry is going and whether machine learning and AI is a good thing. And hopefully by the end you might think that it is. So Rupert's obviously done a phenomenal job of introducing me. But so Salsa Sound, we're a UK startup. We actually are a spin-out company from University of Salford, which is where I did my PhD. And much of the work that Salsa Sound is built on actually comes out of a postdoc project that I was part of, and we were looking at object-based audio and how that could be used to facilitate personalised TV experiences. This is kind of 2010 or something like that, so a long time ago. And we were looking at delivering panoramic 8K content and allowing viewers to zoom in and zoom out and pan around and customise their own viewpoint. And as the audio guys, as the resident audio guys, recognise it's super important. If everybody's looking at something different, then everyone's going to have to be hearing something different, and we're going to have to personalise people's audio experiences on the fly to make sure that what they were hearing matched with what they were seeing. And that's where we developed a lot of object-based audio techniques, and some of which I will talk about today, so that we could understand what audio sources were in the scene and localize them into the right space so that we could pan around. So if you were looking at, say, that goal in a football match, you would expect all the sounds to be coming round about the left loudspeaker. But if you were looking at the same moment, you're looking at this goal, you'd expect things to be coming out of your right speaker. So we needed to know where the sounds were and when they were happening and that sort of thing. So that's kind of the background. And so for us, recognizing that was quite a challenge, and expecting people to do that as a manual process was going to be really difficult. That's why we developed a lot of AI and machine learning based tools to kind of use pattern recognition, audio pattern recognition, to be able to listen to those microphones and pull out the audio sources. So that's where we're going. this is where I come from. So I don't know whether anybody is interested in aviation, but this is an iconic aircraft for me. This is a Vulcan bomber, and the reason I put that up is because it reminds me of just how visceral and how kind of emotive sound can be. So the first time I caught sight, or caught ear, I should say, of one of these aircraft, I must have been about 7 years old, I guess, at an air show. And I'd watched a few kind of rubbish planes go over, things that I'm not interested in. And then when this guy flew over, it like the ground shook. It was so loud and my rib cage was rattling. And it just, my emotional response to that was far greater than anything else that I saw that day. And I still remember that as like this sort of seminal moment, I guess, in my life. Not just because I was interested in sound, but because it had an emotional response. And that's what audio does, isn't it? Like we love pictures, and when you watch a movie, pictures are great. Like without the pictures, it's less easy to know what's going on. But I've got a young family, and if they're scared of anything, I turn the sound off and they're no longer scared. That's the power of sound, isn't it? You don't turn the picture off and go, oh, it's okay. The foreboding sound's still there, but you can't see the shark. You know, if you play Jaws on mute, it's laughable. But when the audio's on, still maybe laughable, but it's also got a small amount of sort of fear and dread. So it kind of got me thinking of like, what makes a good soundtrack? Maybe this is a good place for us to start as broadcasters, to think, actually, what about like if it was a movie, if live sport and entertainment was like a movie, what would we be looking for in a soundtrack? Well, every great movie soundtrack obviously needs a narrative. Without narrative, it's not going to be very interesting. And from an audio point of view, the narrative is made up of diegetic sounds, like, you know, things that add to the story, so keys in the pocket or the slamming of a car door and things like that help you understand the content. And then obviously there's a Foley studio literally in this building where sometimes you need to enhance that a little bit more because you can't actually hear people walking across a gravel path very loudly, so you want to get your Foley engine out and kind of make it sound a bit more punchy, or I don't know, there's hundreds of examples of Foley, isn't there? Like walking through, I love the sound of walking through snow. That's one of my favourite sounds in real life, when you kind of get that crunch and that sort of creak as you go over. And I know in Foley they use like a bag of corn flour, we were talking about this earlier, and you kind of, if you bend it, it kind of goes, and it sounds exactly like somebody walking through snow. And that's just to put a bit of more of an enhancement to give you that, again, emotional connection. But we all know that a lot of the emotion comes through the score, doesn't it? If you watch a movie and it's got this great emotive score, or a Hans Zimmer kind of, it gets your emotions going. So I'm going to pull all these back into the sports arena for you in a second. And then obviously you've got the dialogue. Without the dialogue, it's really difficult to understand what the story is about if you can't hear people speaking to one another and you don't know the interactions between all the different characters. But the best stories, without doubt, are when it gets personal. You know, when it's something that you can actually relate to and you jump in and you feel like you're actually a part of it, and you sort of almost forget that you're being delivered a story, and you know the hours fly by and you're right in there because it matches up with your experience. So these are some things that I want us to remember as we talk about live sports and live entertainment, because I think if you were to kind of do an analogy with the things I've just said, your narrative, those are your kind of on-pitch sounds, or the strike of a tennis racket. If you don't have those sounds, then as a viewer you're missing out on the action a little bit. If somebody kicks a ball and you don't hear it, it's a bit odd, and it's just a little bit less engaging. And I'm going to talk a little bit about Foley and let you know into some of the kind of secrets of how live sports is done currently and maybe is done in the future, and just see a couple of little life hacks that the broadcasters use, which I would consider to be Foley. So we'll have a look at a bit of that and some sample triggering. And obviously we've got the emotion. The crowd brings the emotion, doesn't it? Because the kind of that response of the crowd, the visceral response of the people there, kind of lets us know when something really exciting or really dull's happening. So I'm quite often cooking in the kitchen whilst I'm sort of watching football. I'm not actually watching it, I'm just listening to it, and then when I hear something, the crowd go nuts or booing, I kind of run into the lounge and like, okay, right, yeah, can see what's going on. And then we've got the dialogue, which obviously provided by our commentary team. And then the things that I want to talk about today as well is making it personal, because we now have technology to make broadcast personal. This kind of one-size-fits-all paradigm that we've had in broadcast for several decades now is coming to an end, and we're at a point where actually we can access personalised experience, and with internet delivery and OTT platforms, it's opening up the doors for us to have a personalised experience rather than a generic experience, or we can access maybe really niche sports that historically haven't even been shown to us, and it's very kind of personal, it's for you, and delivered to your device. And then the last one, experience. Like, can we make people feel like they're actually there? And that's something else in terms of like immersive audio. And again, we've seen lots of developments in immersive audio, and even now just using 2 earbuds, you can get that immersive experience that makes you feel like you're there. If you produce the content right, you can feel like you're actually sat and a Vulcan bomber goes overhead, or you're sat in a stadium and you can feel like, you know, when somebody scores a goal, you can almost feel like the Mexican wave as the crowd cheer, like the fans respond, kind of goes around you. So that's live sports. But maybe we might be getting a bit ahead of ourselves, because some of the things about live sport that are important is it's live, and that sounds stupid, but it means it happens fast, it's unpredictable, and things which might be really, really easy in a kind of offline production context where you can put microphones wherever you like, and you can spend 4 weeks in a Foley studio like honing it and tuning it, and you can pan sources around. No one's doing that in a live context because it's really difficult. Like in a live sports context, it's very, you've got to respond, you've got to react, there's lots to do, and actually mixing the audio is just one of as I was speaking to a sound supervisor in Germany, and he reckoned that mixing was about 20% of the tasks that he does during a broadcast, and he's the audio mixer. So it's quite sort of glaring stats, because there's all the comms, and then there's kind of like troubleshooting, there's kind of monitoring all the different feeds that's going on. There's a lot that goes in to mixing an event that isn't just riding faders. But the problem with it being live, and the problem with it being very reactionary, is if you blink, if you lose concentration for a little bit, you've missed it, and the viewers have missed part of the narrative. So one of the I was putting together a demo just yesterday actually of some of our tech, and I was looking at I've got a recording from a Premier League football match, and just without even realising it, I'd got a recording of all the microphone feeds, and then I've got a recording of the ball group, which is what they call the kind of the mix of just the pitch side microphones. And I looked, and at one point it just goes to 0. There's nothing comes out. And what had happened basically is they had a problem in the truck, and the sound supervisor couldn't mix those microphones anymore. So then for I think it was about 2-minute section, nobody heard any of the on-pitch sounds, because an already stretched team is having to respond to some kind of problem somewhere else, and therefore the viewers are missing out on some of the narrative. So live sports is really, really tricky. And when you're looking at personalizing it, maybe you want to use multiple different camera views, or you want to do something flashy for a slow-mo or a replay, or like a spider cam shot. It's just adding more and more layers onto something that's already really, really tricky. So I thought it'd be good just to keep this little framework that I put together with the kind of, how many are there? 2, 4, 6 different attributes of what makes a great dialogue and just use that as our kind of map, I guess, as we go around. So this is a standard practice, well, it's some elements of standard practice of how, in a current broadcast context, sound supervisors are trying to pull out that narrative, those diegetic sounds, so the on-pitch sounds or the on-rink sounds if we haven't got any ice hockey there. So where do I start? I'll start on this top one. So this is American football. You see this guy with the weird satellite dish thing. So there's a parabolic microphone that's see-through, so you can see what he's pointing at. And if you ever have a go with one of these, it's absolutely amazing, because if you point it at like an individual, you can hear what they're saying, and you move, 3 degrees off or something, 5 degrees off, you can't hear them anymore. So what this guy's doing in that picture is he's pointing. He's got or literally like crosshairs. It's like a kind of a gun, and he's pointing it at where the ball is, so that it's zooming in on that audio. So you just hear the kind of crunch and the thwacks. And if you've ever heard American football, you will, or seen, whatever. If you've ever seen it on the telly, you'll know exactly what I mean. They love the kind of the sound of pads and helmets and cracks and crushing bones and stuff. But in my opinion, it's like quite a horrible, harsh sound, because these parabolic microphones, they work on acoustic focusing, and they're not very broadband. So I think it's quite a harsh sound on the ears. But what they will do is they've got 5 of these individuals around the field pointing the parabolics at where the action is, and then this is a terrible picture because you can't see what's going on at all, but nonetheless it's contextual, it's true, it's an actual photo. There's a sub-mixer there who's taken those 4 or 5 parabolic feeds and is deciding which one should be the main one, so which one's closest to the action. And then that mix then goes to this guy who's doing the main program feed. So look how many people you've already got in action. You've got 5 mixers, 5 microphone people, and then you've got a sub-mixer, and then you've got this guy who's got also got a team of people. And this is just that's 6 people involved in just getting the on-pitch sound. So that's how important all this stuff is to broadcasters, particularly in the States. And then if you come to the UK, we don't tend to employ so many people, but we do employ more microphones. Not that you have to pay them or have any national insurance or anything for those, but the very standard setup for this could be like the Premier League or La Liga in Spain or the World Cup. World Cup uses a few more, but it's very standard to have this kind of mic layout where you've got sort of 3 microphones down each side of the pitch. And you might think naively, great, it doesn't take any mixing, does it? You deploy your microphones, that picks up everything and go. But it unfortunately picks up everything, which includes the sound of 60,000 screaming fans. And so if you've got the other side of the pitch, somebody kicks a ball, but this side you've got 40,000 screaming fans, guess what? You don't hear the sound of the ball being kicked. So my friend Ian is mixing this game and raising only 1 fader at a time. So when the ball goes near to one microphone, he'll push that fader up, and then as the ball moves somewhere else, he'll pull that one down and push the other one up. And then it'll just it's like playing the piano, but with 12 microphones and 10 digits. It's hard. And you've got to, is watching the camera 1 feed there, that's kind of the wide shot of the pitch, and just always like fully attention given to just mixing those microphones. So you can see now why I've got this recording where it suddenly went to 0, because if he's not able to watch that screen and do this, and maybe he's monitoring the sound of the stereo mix or the 5.1 mix or the Atmos mix or whatever's going out, it's hard to do 2 things at once. But that's how football in the UK and, like I say, in Europe is mixed at the moment, and it's hard. And they work really hard to make that sound as punchy and as engaging, and that it contains all of the sounds so that you get the full narrative. And actually maybe, so it sounds a little bit like FIFA, or what's it called now, FC 24 probably. So it sounds like a computer game experience, because that's what viewers are used to. We're used to having like really punchy kicks sounds. So I mean, I've only just done American football and football. Ice hockey is very similar. Basketball also is a kind of a chasing exercise of making sure that you raise the right faders at any one time. And then Foley. So this is kind of really about fake sound or kind of augmented or hyper-real kind of sound that maybe draws attention so that it really pulls the audience in. And maybe some things are too difficult to mic up. So it relies on a little bit of audio skullduggery to make it sound as good as we want to. So I've got a few examples here. So that, I'll start in the top corner because that's sensible. The skiing, for example, if you imagine somebody skiing miles and miles away and the track for the cross-country skiing, I don't know, it could be like a 7-kilometre track and they're doing loops. They're not going to put microphones all the way around that venue, or it might be really difficult to do so, and running the cables or running wireless microphones might be just too difficult and you might need too many of them. And so if you were to squirrel your way into like an OB truck at the Winter Olympics, for example, you might see somebody with a MIDI keyboard with a whoosh, 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 whoosh sound of somebody skiing. And this, I'm not making this up, this is true. And so it's giving you that impression of it, and then when you take a step back, you're like, oh yes, there are no microphones, and these skiers aren't wearing microphones, for example. You know, it's not all the time like that. They've got kind of boom microphones and some kind of hyper-directional things, but for other sections of it, there will be triggering samples. Or take the gymnastics, for example. If you've ever been to a gymnastics event, there's always lots and lots of things going on. It's not, the TV only shows you one thing, but actually you've got the pommel horse, you've got the floor mat thing where they do flips, and you've got the rings. I don't know, I can tell I'm not a gymnastics aficionado, but and the well, lots of events. And so in this pommel horse example, the way that they focus the user, the viewer, onto that content is by contact microphones. So you can't, when somebody's on a pommel horse, you don't really hear all the squeaks and the doo 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 if you were close to it. But when you're watching it on the TV, it's really loud, isn't it? Almost too loud. And the secret is to put kind of, rather than microphones, to use contact microphones or accelerometers that pick up all those squeaks and those kind of thuds, which help you draw in your attention. Even though there's lots of events going in, you're concentrating on the pommel horse. So it's kind of, it sounds great. It's not what you would hear if you were there. So it's kind of, I'd kind of put that in a semi-Foley category. Or the darts, for example. I mean, who's ever played darts and heard their dart go into the board with a that like breaks your subwoofer? Have you ever thought about that? Like, they're playing with a hollow board? What's going on? It's actually just triggering the sound of a bass drum when it goes in, just because actually the sound of a dart going in is relatively quiet. And similar example with archery, they do the same, and they even make the sound of the as the arrow goes through the air, so that you get that, just seems a bit more kind of like Robin Hood, Prince of Thieves kind of vibe going on. And the rowing, very similar actually to the cross-country skiing, you know, somebody with a sampling engine, because rowers do not let you put microphones on boats. So, and even if they did, you've got to get the signal wirelessly somewhere, but they're going at rate of knots down a river, and that's going to be a challenge, isn't it, really, to get a consistent mic feed. And when it zooms in on a particular boat, that's really difficult. So we've got somebody with a sampling engine. So all a load of cheat, isn't it, really? And there's another sort of famous-ish example. Do you remember the Football World Cup in South Africa? What's the overriding sound that you remember from that World Cup? Vuvuzelas, exactly. Horrible, isn't it? Like, ruined everything. And an unnamed broadcaster came up with a way of getting around the sound of a vuvuzela. Turns out playing a crowd loop from Coventry City Football Club to drown out the sound of a vuvuzela was one of the techniques. So piping in fake crowd so you can lower the sound of the real crowd so that vuvuzelas weren't so annoying. So I call it audio sweetening, making things sound better than real life, and kind of hopefully more enjoyable, hopefully more engaging. And obviously let's go now onto the emotion. And we talked about crowds, we talked about fake crowds, and this happened, didn't it? This is a COVID, I mean, maybe I haven't included enough seats. This is a goal, or a near goal, during COVID. And I hated watching football during COVID because it was boring, because there wasn't the crowd to get me, or maybe I'm just easily led, but there wasn't the crowd to get me hyped up about it. And obviously, I mean, Salsa Sound and amongst other companies, where this is our solution, was to kind of generate fake crowds, because we needed to we lost the emotion all of a sudden from our great storytelling soundtrack, and so we had to put it back in with fake loops. And there's a whole load of examples where people press the cheer button and we're like, oh, it didn't actually go in, and things like that, which was all fun, but it wasn't as good as when the crowd actually came back. And when the crowd comes back, we can give viewers at home, that fan experience, that kind of visceral and hopefully like immersive experience using spatial microphones, and kind of make it a bit more up close and personal, like BT Sport, when that was a thing, we're doing the hashtag no filter, which is a bit more like, let's give people that experience of actually being, around the venue. And so I love the idea of giving people more of a crowd, a fan experience. And we worked with Manchester City for a number of years doing that by putting immersive microphones right in the heart of the South Stand, and you can hear the home fans over there, and the away fans, well, it's the other way around, the away fans the other side, and having a sort of chant off. And when you hear that over binaural or over like a multi-channel setup, it just sounds absolutely incredible. And it really, it's much more engaging and much more kind of emotional. So next on our 6-point list, dialogue. Obviously, how we deal with commentators and how broadcasters deal with commentators is super duper important. Speech intelligibility, I think, is probably one of the biggest problems in broadcast that we're facing at the moment, is kind of the speech intelligibility, and like with an aging population, like we need to allow people to actually hear that content and understand what's going on, and people shouldn't be kind of craning their ears to try and understand what's going on. So having good high production value on the commentary and reducing crowd spill is a very significant issue. And part of this talks about object-based reproduction. So we need to have a really clean object, a commentary object, so that it can be manipulated, it can be delivered to users so they can actually tune their own mix potentially. Obviously we need to remember loudness criteria. So this is another thing that broadcasters need to do, is remember that they need to hit certain loudness criteria. So just yet another challenge. So I'll come back a little bit to that as we go on. But the other thing I said was important would be to make it personal. And so this is something that broadcast doesn't do particularly great with a traditional lens. So traditionally, broadcast has been more like this kind of food service where they all look the same and everybody gets the same thing. Everybody's tunes into BBC One, they get the same mix, the same delivery of the content. And it's not particularly sustainable. It means that if you wanted to offer a stereo mix and a 5.1 mix, the sound engineer has to mix twice, has to monitor 2 different feeds, and then you put an Atmos in there, and then all of a sudden they've got to monitor and mix 3 different productions because they're delivering it in a channel-based format, very kind of one-size-fits-all, and it's catering for a target kind of reproduction system. And there's no personalization, and it's limited in how immersive it can be and kind of what objects can interact with. Contrast that with a kind of object-based world, where instead of giving everybody your meal, you give everybody the ingredients and the recipe, so all of the different audio assets, and they're kind of a metadata map that tells you how to to mix those, and actually you're in a much better position. All of a sudden you've got something it's fully scalable, so you can roll that out to anybody over different platforms. It's completely format agnostic. It can even be mixed on the fly. It's immersive because you can pan sounds around. It allows even interaction. So if you wanted to boost the level of the commentary or reduce it or whatever, you can do that, and you can fully personalize your sound. You could imagine being, I actually, as a Man United fan, I want to sit with the home fans rather than the away fans, or vice versa. And so giving everybody those mix ingredients, those kind of pre-mixed stems, and then like a metadata map that tells you how how the original sound wants to be put together, is definitely the way forward, I would suggest, and means that we can do a lot more and deliver a lot more to audiences. So looking at, I wasn't expecting the animations there, looking at kind of object-based formats that are currently kind of out there. A lot of people have heard of Dolby Atmos because it's kind of leveraged over cinema, and we've seen Sky deliver content, and BT Sport and broadcasters worldwide deliver content in Dolby Atmos. I would say that it's kind of more of a hybrid between a channel-based and an object-based world, because if you were to watch something in Dolby Atmos currently, you experience the immersiveness, so you've got loudspeakers in the ceiling, but actually you don't yet have access to be able to control the different objects in your scene. So it's more in terms of live broadcast for sports, is actually a bit more like a channel-based format, I would say. And as things evolve with that, and as they develop, and we move into kind of AC4 encoding and delivery, there will be a bit more ability to be able to interact with objects. One that's a bit more comprehensive, and I think is probably closer to a pure object-based paradigm, is MPEG-H, and I'm going to talk a bit more about that because we've done some good work with Fraunhofer directly with that, and that is very much the kind of recipe idea that I said. So it's kind of creating objects or components and giving the user the ability to interact with those and to compose their own scene. And what's really cool about MPEG-H is that as a producer, you can define what people are and aren't allowed to do. So you could say, you can make the commentator 9 dB louder or 9 dB quieter, but you're not sort of giving complete free rein to do whatever you want. There's a constraint on what the interactivity. So that's been really helpful in communicating this to kind of real world mixers who may be a bit precious about the mix that they're delivering, because you're saying it's not like we're giving free roam for people to ruin your mix. Actually, you can define how much you want them to be able to change that. You can even define how much you want them to be able to pan different sources around. And then another good thing about MPEG-H, you can have switch groups, so you could swap between, say, a French commentary and English commentary if you wanted to. A click of a button. DTSX deserves a mention, although it's a bit less in the kind of live broadcast space. It's more on the kind of the VR space and Blu-ray and things like that. And something that I want to draw your attention to, because I think it's cool, is SADM, so serialized ADM, ADM being the audio definition model, and that is a kind of an object-based framework. And actually, if you were to go to Netflix studios, for example, they will have ADM masters that define how the content was mixed, and a serialized version of that is, as it sounds really, it's kind of giving it in chunks so that you can do live workflows with ADM. So it means that you can actually define how objects interact in space, maybe even dynamically, so you can have sounds going above your head and moving around and things like that. And it's important because it's designed as an interoperability standard, so it's kind of what links these together. And I think we'll see more and more tools being made to do serialized ADM, and then with the ability to then produce like an Atmos master or an MPEG-H master. And I think my prediction is that you'll see this change quite a lot in the next year, even because this standard, the ST2110-41, which is how that whole kind of audio plus timestamps plus metadata is going to be transported an IP stream. And not wanting to bore you, but we've been waiting for a long time for that standard to be ratified, so now it has. I think we should see lots of kind of manufacturers really coming to the fore and creating tools that allow people to create SADM masters that they will then broadcast, and then you could interact with that at different production points and even deliver to end users using something like Atmos or MPEG-H. So I've stolen these slides from Fraunhofer, so thank you Yannick and co. Just so that you can understand a little bit more about the MPEG-H setup, because I think it's quite a good exemplar of how object audio can find its way into real people's real homes on real content. And if you were to go to so Brazil, this is kind of part of the Brazilian broadcasters' everyday delivery to homes. So personalization and accessibility is a key one. So like I said, one of the big problems with kind of dialogue level and like the inability to enhance the dialogue for standard linear broadcast is being addressed, because dialogue can be its own object, or audio description can be its own object, and they've got clever processing that allows you to do dialogue plus, and it can even do kind of the right ducking and things like that automatically. So there's the kind of the personalization and accessibility element to it, and like I said, you could do switch groups, you can switch between home fans and away fans. It's immersive delivery, so you can deliver this over a 514 setup or a 5.1 or 5.12, whatever you've got. And also it's got this kind of, it's universal delivery, so it will go across any replay device that you've got. So it's got that format agnostic element. And I've put this slide up because this is actually a test that we did with Fraunhofer. So this is Manchester City versus Chelsea, and we produced different crowd mixes. I'm not quite sure what it's called, fan curve, but there's the stadium atmosphere, there's the fan curve, there's a pub mix, which contains a different balance, because if you're watching it in a pub, you've already got fans around you, so actually you don't need the stadium fans to be as loud, but you still want to hear the commentary and you still want to hear the ball kicks and stuff. So those are 3 different crowd mixes that we were allowing users to swap between, and then you can turn the commentary on and off, or in this one you can switch between English and German. So you see, imagine how powerful that is, because you're just sending one more object, but you're giving the ability to, you're giving the content to 2 totally different demographics, the German audience and the English audience, but it's one broadcast stream. So it's super duper powerful. And this is how this is a kind of an overview really of how it works. So this is actually a kind of a specific use case. So this is going down an SDI, which is, you know, fairly old school sort of format really, but it allows you to have 16 audio channels. So the way that it works is that the first 15, those are the components, the audio components that you will give users the ability to interact with. So you might have 5.1 home crowd, 5.1 away crowd. I mean, is that 12? I'm going to get myself into knots here. And then you might have 2 different commentaries, 13, 14, and then you might have an audio description. So there you've got 15 audio channels. And then importantly, you have this on the 16th channel, you have what's termed the control track, which is the metadata. That's kind of like your recipe. And that defines those interactivity settings, like whether you will allow users to pan things around, or whether you will allow a changing in volume, or whether you've got a switch group being like, you can have this one or this one. It's like a sort of a flip-flop. And that's defined as a control track, which is actually a PCM audio stream. So it all goes down the same SDI pipe, and then it'll go into an encoder and then delivery. So it's a really neat system actually, because it's got all of the audio components and the metadata just going down 16 channels of audio. And that's a kind of a basic overview of how it works. And I'm sure if you want to know more, Rupert probably knows 10 times what I know about it, but I just know it's very flexible and is fun to work with actually. We've developed as part of our tool set. Okay, everyone's still with me? Bingo. Last one on our list of 6, experience it, feel like it happened to you. I don't want to talk too much about this other than we need to be ready for next generation experiences. So this is a project that we worked on a couple of years ago, and we were looking again at kind of delivering XR experiences over 5G, and hugely complex project involving lots of different partners. Again, we were doing the audio and making it so that people can interact with sounds differently, and we did a boxing example. So this is where you've got like holograms. This is a company called Condense that do some really cool stuff where they're doing volumetric videos, and you can actually look around. You can, if you've got some kind of AR glasses, you can actually have a kind of mini fighters on your coffee table, and you can look at it from different angles and see how that punch was really delivered, or the strike in tennis. You could actually kind of look at the shape of the bodies and just like marvel at the athletes, really. Or this example with a motorsport, we're actually using XR. You can deliver a whole new amount of content with virtual screens and things like that. And you can imagine there's a lot of complexities around the audio that would mean that we need to know where the sources are and how they should and can be interacted with. So again, it's about understanding the audio scene and knowing what and where the objects are. And this kind of thing is going to probably become more and more prevalent with stuff like Apple Vision and things like that. So we sort of set the scene as to kind of what are the elements that we need if we want to do some good storytelling. But really, I would suggest that when we're doing all of this manually, we're struggling. Like, are we storytelling or are we just surviving? Do you know what I mean? Getting anything out on air, I always think is like a massive achievement. And if you ever go to an OB truck and there's cables everywhere, there's people rushing around like 10 minutes before the show starts, I just think, this is incredible. Like, these guys are amazing. Like, to get like high quality content that goes out and that you can experience in 514 and things like that. But really, we are asking people to do more and more in less and less time, with a more and more budget reductions, basically. And actually, it's putting a strain on an industry where there are already like massive personnel shortages, and there is a skills gap. And we're asking content to be personalised, to be immersive, like new formats, new experiences, and we need to have a swoosh as the spider cam goes across the field and all these things. And it's really tough. And then when you say, as an academic geek, I love talking about object-based audio, but when you mention that to people who sit in a real truck, they don't want to be producing objects and authoring metadata, and it's kind of like, I'm already doing loads of stuff, why are you giving me more things to do? I mean, just being like really, straight and honest, that is what you come up against. So we have this kind of thing of like, we want to kind of facilitate these great experiences, and we want to make great stories, and it's like live sport is competing with Netflix. You've got like on your Apple TV, you flip between Netflix and you go to your sports. You don't want to be like immersive film, incredible sound, and then you switch on the football and it's really narrow, rubbish, stereo, can't really hear what's going on. So as people in the broadcast live sports industry, we're competing against Netflix actually, and I mean, or Disney, or or Apple TV, whoever is producing this content, and like need to sort of bring everything together. But we are struggling and we're a bit stretched, and I want to pose the question, like, can AI, can machine learning help us out here, so that not only do we just meet the status quo, but can we do better? Can we offer better things, new things, more personalized options, and kind of bring audio to the fore, really, and tell great stories, because that's what we're about. So to sort of jump into an AI swimming pool, it's always just good to kind of figure out, what do we mean? Because, I mean, last year, AI has just been a catch-all word for magic box that nobody understands, I would say. You know, it's like, you've got a problem, throw AI at it, and boom, magic happens, and all this kind of like content gets generated. So I always think it's just worth taking a little step back and thinking in terms of audio and AI for live audio, what do we mean? Like, what am I actually talking about? And it's probably less of a magic black box than you might think, because really it's just about getting a computer to make a decision for you, which seems a bit more friendly. And really, in terms of AI, it's probably, some people probably wouldn't refer to it as AI. It is more on the machine learning, neural network side of things. I guess key to remember with any AI actually is that you do need to teach it stuff first. They're not like salient computers that suddenly know everything and can do all things. They need to be taught. So it requires humans and it requires historic data to teach these algorithms how to do the very, very specific niche task that it will be good at. And because it's not a one-size-fits-all, it's kind of develop an application for a specific role. And this is what we're talking about here today. But I think the challenge that I want to propose really is about seeing microphones differently. I think it's always, we've looked at microphones as being sound recorders. And I think if you were to ask anybody what's a microphone, it was, oh, it's a sound recording device. Whereas actually I think it may be a nuance, but it's worth thinking about microphones as sensors and as data capturers rather than as audio recorders, because actually there's a whole lot more that a microphone can tell you than just what something sounds like. There's a whole lot more data coming in through that sensor that can be mined, can be useful, and can be used throughout other parts of the broadcast chain or the production environment. So that audio can essentially add a bit more value, and if we start using it as data, then we can start doing data processing techniques and using AI on the numbers rather than the audio samples. And I'll talk a little bit more about what I mean by that in a moment. But one of the key things when I talk about machine learning and audio mixing and AI, is automated audio mixing. And this is a great application for machine learning. And what I'm really talking about is audio event classification. So the minute you can classify specific events, whether it's the sound of a ball being kicked or the racket strike or the sound of two men hitting pads together in that American football context, or the sticks in hockey or bounces in basketball, if I can teach an algorithm to classify those events, to listen to an audio feed and go, that sounds like a basketball bounce, or that sounds like a squeaky shoe, then I can write some semantics that can tell an audio mixer what to do with this information. So you say, microphone 3 has detected a ball kick. It can crossfade to that microphone automatically. And you can imagine, if you go back a few slides, to my microphones around the football pitch and Ian dynamically mixing those microphones. Actually, what we could do is write, and this is what we have done, is write an algorithm that's listening to all those microphones, and when it detects the sound of a ball being kicked, it can add that microphone into the mix automatically. And all of a sudden it's producing an automated mix of the sounds of the pitch, so that the sound engineer can be freed up to actually create or curate these great immersive experiences that we were talking about without being glued to the screen, sort of doing this sort of thing. So audio event classification could be referees' whistles for like adjudication decisions, or you could even trigger a graphic every time the referee blew his whistle, for example, just to draw the user's attention to, you know, an event has happened. Or you could have even have an event like a notification on someone's phone, maybe, to say, oh, you might want to stop cooking and have a look at the TV because the referee's just blown his whistle, so something's probably happened. And obviously, you cannot talk about AI audio without talking about how it pertains to speech, because I think that's the most prevalent use case of AI audio. If you were to Google AI audio, probably speech things would come up. So automatic detection of speakers, or kind of revoicing speech, or text to speech, those kind of speech to text, I say. So all those things. So this is a standard machine learning workflow, if you can follow. So we've got many hours of recorded content. They need to be manually tagged. So I'll use the football example because it's the one that we've kind of had most traction with. And so for that, we're listening out for the sound of ball impact sounds, like bounces and headers and kicks. So trawl through hundreds, if not thousands of hours of audio and tag every time there is the sound of a ball being kicked, regardless of how much background noise. Then it goes through a DSP processor, and in our case, we listen for MEL spectrograms that have a kind of a time and a frequency component, and then that goes into a neural network trainer that takes every single example of a kick and is essentially looking for those patterns that might be difficult for a human to understand because they might have multivariate patterns, multi-dimensional patterns. But a machine learning algorithm is really good at that, at traipsing through and producing what would be a trained model of all of those examples, and then this is how it interprets it. And then you deploy it in the real world, so it's very much a mirror image of what's on the left-hand side. You've got the live audio going in this time, and the same DSP, that's really important, else you're giving it, you need to give the algorithm the same information that you taught it, else it will get very confused and it will just give you gobbledygook. So it's quite pernickety, really. Goes through your neural network that's running your trained model, and then you have a classifier that can say, yes, that's a kick, no, that's not a kick, at every single point. So it's slightly more complicated than that. We have a transient detector on there as well, else you're ending up give too much information to your neural network and it gets a bit flooded. So a transient detector is useful to say, at least we know this is a transient, so have a look at that and see whether this transient fits the pattern of the transient of a ball bounce or something like that. So there's a few more technicalities of how you can help out your algorithm, because actually it's really quite challenging to create these algorithms. It's not just to kind of sit down and click your fingers. It takes months, if not years, of kind of tweaking and training. But I guess just a few sort of headlines of ways that you can help the AI. Lots of data. The more data you can give it, the more examples you can give it, the better chance it is of understanding its real-world environment, of understanding the sounds that it experiences in the real world. The data has got to be accurate to what it's going to experience in real life. So there's no point in me training it on data of me kicking ball to Rupert and back, because that's not the same as what it will experience in a crowd of 60,000 fans. We need to give it contextual information. So we took thousands of like real microphone recordings that we got from several broadcasters around the world. It was just the actual raw recordings, and that's what we use to train it, because that's what it's going to experience in the wild. The data representation that you give it is really, really key as well. So you need to figure out a way of finding a DSP representation that's going to be really efficient and that's going to give your algorithm enough information to learn how to kind of classify the events that you're looking for. And then a really big issue for something like detecting the sound of a ball kick is this kind of unbalanced data set. So you can imagine that if you had the worst neural network in the world, and 50% of the time it told you that it was a ball kick, and 50% of the time it told you it wasn't, then it would be right approximately 50% of the time wrong, because most of the time there isn't a ball kick happening. So it's a difficult challenge to kind of tell a neural network most of the time you're not going to be hearing a ball kick. And so it could get to the point where it would say, sorry, a better example is if it always said, this is not a kick, this is not a kick, it would be correct 99.99% of the time. Because if you look at audio samples, you've got 48,000 a second. Most of those do not contain the sound of a ball being kicked. So it's important how you create your data set so that you understand those imbalances, so that you can train a neural network sensibly to kind of understand its environment, that it's not going to get that many kicks. And there's lots of different sort of complicated techniques of ways you can go around that. And neural networks are always optimized by this idea of hyperparameters, of how many times you pass it around the training loop and kind of what your batch size is and how long you do that for and things like that. And that is the thing that nobody really talks about, but that takes absolutely ages, because to tune those hyperparameters, you have to run your network, your training, lots and lots and lots of times, and you're trying to optimize it and get the best performance out of it. And that can be really taxing, especially if you've got an unbalanced data set, like I've just said. And then I think another challenge that we have in the live world is that it's got to be live. So time is of the essence. And also from a computational point of view, we've got to be real-time safe. You can't have a glitch in your audio stream. That would be an absolute disaster. So you've got to make sure that you've done all of your processing in the time of one audio chunk buffer. So that's a challenge, and we've come up with kind of fallback options where you say, well, if you haven't made a decision on this within 1,024 samples worth of time, then bomb out and make sure that the audio stream carries on going. It's better to not detect a kick and keep the audio going rather than keep waiting and have a dropout or a glitch and things like that. So it's really important that you choose your right network architecture as well, so that you've got the right size of network. If you have a really huge network, it might be absolutely bomb-proof in terms of how well it is at classifying events, but it's kind of a bit bloaty. It might take ages to run, and you can get problems, and you might find that you've only got enough CPU to run it on one microphone, and we need to be able to run it on 20 microphones, for example. So choosing your network architecture. It's kind of important as well, I guess, to think about GPU versus CPU. A lot of neural network stuff runs on a GPU, but when you're running in real time, actually, it takes longer to send it to the GPU. So it doesn't actually really help us in a live context. If you were doing huge video processing and you're not doing it in real time, then sending all the data to the GPU, yes, it takes a little while, but it runs a lot quicker. So by the time you get the data back, it's useful. But in an audio real-time world, actually that's not particularly useful. So just worth kind of mentioning that. And some other stuff, I mentioned it before, about kind of reducing the number of times you call your neural network by putting a pre-filter in. That's why we had that onset detector. So you're not sending every single audio sample through the neural network. Actually, you're saying, right now, you can look at this particular instance because we think we've got evidence to believe that there may be an event there. So there's lots of trade-offs, lots of things to consider. It's all fun, and it all takes ages. But there are lots of possibilities outside of just audio mixing. So I was saying about viewing microphones as sensors rather than as audio capturers. And so it's not just about what you can do with number one, which would be automated, or some people prefer the word assistive because it feels less intimidating, audio mixing. But why has that happened? Projector's just gone off. But maybe it got too hot or something. I can carry on talking, though, without projector, I think. So we talked about automated audio mixing, assistive audio mixing, and I talked about what did I talk about? Audio event classification. But there are loads more uses of AI in a live broadcast environment than what I've just suggested. So things like setting up your desk. Like maybe you could have an algorithm that's kind of automatically detecting what microphones you've got in the scene. So if like that sounds like a crowd mic, that sounds like a pitch mic, and then it could populate the parameters like the EQ and the processing on a desk automatically. That would be kind of cool. That would save a whole load of time. You'd be kind of allowing a sound engineer to get up and running a lot quicker if you could classify microphones and things automatically and suggest audio processors. What about automatic detection of errors or problems in an audio stream? So you don't have to wait for a problem to emerge or to be heard. So a classic problem, particularly in the UK, is when rain gets into one of these condenser microphones, kind of goes, but you only find out that that's happened when the sound supervisor goes to fade to that microphone. It was like, oh, that microphone's dud, and has to select another one. But if you have an AI running in the background, it can say, just so you know, mic 5 is goosed, don't fade to that one, or it could automatically run a mute on the desk or something. So I think that would be good. I really love the idea, completely outside the kind of audio world, really, but in terms of real-time metadata extraction. So understanding kind of like where was the play at different times, where was the referee, and when did the referee blow his whistle, that provides stats to other parts of the broadcast workflow. So, you know, for example, if you don't, it's 3 o'clock on a Saturday and you're not allowed to watch football, but you've got the live text. Actually, you could have like a heat map of where is the ball at this particular point. If you could use AI to pick out the ball kicks and then triangulate. So I like the idea of doing things like that and tagging that, and just it wouldn't be a kind of one data stream to save the world, but it would add into lots of other data streams and help cross-reference some of those. And we talked about enhancing, or did we? We should have done. Talked about enhancing pitch sounds. So one of the things that our engine does is when it detects a ball, it can add the sound of a ball kick. So it does that Foley stuff that we talked about. So for example, it can detect the sound of a kick in the middle of the field that you might not really hear particularly well, but the neural network can detect it. And so just putting a sample in the background that's exactly in time with the kick that you detected and has the same kind of audio attributes as the kick that you detected, but is a completely clean sound, just elevates it in the mix, and where kind of distance attenuation and the ground attenuation has stripped out some of the high frequency, you can put that back in again with a sample. So that's kind of cool, really, I think. And another example, noise reduction is a really big use case of AI, and basketball, for example, where they have a really, really loud PA system. So running an AI that's listening out for the PA and can actually create an intelligent mask that could allow you to reduce the sound of a PA. Because although you want to put some of that in, if you were to listen to the broadcast feeds, the minute the PA comes on, you can't hear anything. All you hear is the PA. And it's great if you're at the event. It's really annoying if you're watching it. I find it slightly frustrating, is possibly a better turn of phrase. One that I'm really pumped about, and we're hopefully starting a project on this soon, automatic highlight generation. So if you imagine you've got, at the moment, when somebody wants to put highlights together, it will be somebody sat in the BBC studios watching TV and going, oh yeah, we'll cut out that section. Oh yeah, we'll use that section, this section. And then they put together some kind of highlights package that's X number of minutes long. And during the World Cup, I'd get up in the morning and I wanted to show my kids. I was like, oh, you missed the Italy game last night. You've got to watch this. That was an amazing goal. And I wanted to take them to school, and we had 13 minutes, I think it was, before we had to leave. So we didn't have enough time to watch the whole game, but the highlights were 2 minutes long or something. I was like, I want a 13-minute highlight package. Why can't I have a 13-minute highlight package? And so I thought one of the cool ways you could approach this would be to use the sound of the crowd, and using the fact that the crowd tells you which bits of a game are exciting and which bits are boring just by how they respond. It's an involuntary response, isn't it? That when something exciting happens, they go, ah! When something boring's happened, they're flat, or they boo, or they applaud. And so I thought it would be a good idea to analyze and do a sentiment analysis of the crowd sound, so that you could decide, you could kind of almost graph out during the game which are the exciting bits, which are the bits that were a bit boring, which bits applaud, and you could assign each segment a kind of excitement metric, and then run an optimization algorithm. So you could say, give me a 17-minute or 13, I said, didn't I? 13-minute highlight package of the first half, and it could select all the clips that it thought were the most exciting that fitted into a 13-minute window, and then it could deliver the highlights. That'd be a cool idea, right? That would make me very happy if I could do that. So we're working on that one as we speak. And I mentioned about graphic triggering, like on a whistleblower or something like that, or going through archive content and running these algorithms on the archive content so you've got a better idea and you can mine that data that we've got a lot of. And looking at additional tracking data sources, like the sensor in the ball at the last World Cup was something that we used recently as well. Auto captioning, language detection, so you don't accidentally fade to French instead of German. If you've got like 30 languages coming in, it's fine. You might be able to tell the difference between English and German, that's easy. Bulgarian and Russian, I have no idea. Like the nuances of certain languages. So using an AI to make sure that the language that you're sending out is actually the language that you think you're sending out, I think is really important. And then a couple last two, content-aware upmixing. So there's lots of upmixers out there that could go from like stereo to 5.1, but they're quite content-specific. So it might work really great for sports, but be a bit rubbish for music, or the other way around. Or it might, in certain contexts, when you've got loud crowd, it doesn't work. And so it would be really cool to write an AI that could understand the best way of upmixing content based on the actual audio that was in that stream. And then last one, just a bit of fun with like predictive mixing, actually predicting where the pattern of play is going next, so that you could fade that microphone in advance. Like, it's 80% likely that he's going to pass the ball up the wing, so let's fade that microphone up first. So I think audio stands to have a big role to play in the AI world that isn't super threatening, but actually it's releasing like really good opportunities for viewers and for producers. So I feel like the future's rosy in that front. So I'm just going to go through quickly. We still got time, haven't we? I think to rattle on, and then we'll do some questions. But just some kind of real-world exemplars. So this is ice hockey. All the microphone feeds into a MADI interface. Then we've got the real-time analysis. We can pick out some metadata if we can do the triangulation, and with our already trained audio template. And then this, I guess, is key to remember, that in order we need to run at a bit of a latency, because an event has to have happened in order for us to have detected it. That's always a question that people ask. So it takes 40 milliseconds. It takes basically 20 milliseconds to detect the event, and then you need 20 milliseconds to do something about it. So it's not a processing latency. It's actually like just a physical requirement, a conceptual latency, if you like. The event has to have happened before you can detect it, else you're always running, you'll miss everything because you're always being too reactive. Object-based production. So this is actually a bit that was kind of missing from the stuff that I was talking about before, is this localization piece. So picking out the objects and creating a pitch stem is one thing, but being able to actually localize that in space opens up a whole new realm of what you can do with object-based reproduction and those kind of next-gen experiences. So we use a time difference of arrival technique, and then we basically plot this kind of thing that gives us the most likely location of the source. And actually, this is slightly old. We've gotten a more efficient way of optimizing it now. So we just kind of run an optimization routine and go, based on the sound, based on the time differences at all these microphones, this position has the highest probability of it being the place. Another example of what we've been working with broadcasters is auto-versioning. So if you've got, say, we're out at Qatar last December, and we've got 50-odd languages coming in from different broadcasters, radio and TV, and so having something that automates those mixes, that's where our software fits in. So you can automate the mix. You give it the international feed, which is basically the crowd and the kind of the diegetic sounds, and then it will automatically balance the commentator on to give you the right ratios and the right sort of speech intelligibility. So I think that's a really good use case of automated software and making sure it hits the right loudness requirements, which is a big deal. And then I've already said about metadata adjustment. So this is just a nice depiction. You see how obvious that is, that that's a whistle. You don't need AI to tell you that's a whistle. I don't think that's the fundamental. And then you've got the harmonics that appear. And so a referee's whistle is almost exactly 4K. But we worked with FIFA, and we trained up a neural network to understand the sound of a whistle. And it's absolutely amazing, really, because when people do that thing, I really wish I could do it. I always think it's a power move when people just go really loud whistle with their fingers in their mouth. Weirdly, that is also almost exactly 4K for most people. I don't know why, but a neural network can understand the difference between that and a referee's whistle, and can be useful for metadata and for adjudications, decisions, and things like that. And we're coming to the end, but this is another project that we worked on where we were doing automatic ducking of translators. So when you have a press conference like out in Qatar, you don't know whether someone's going to ask the question in English or in French or in Arabic or whatever, but they have to broadcast it in English. So they historically have had somebody manning the fader for the translator, and they would duck the native speaker and push the translator up. So we wrote a voice activity detector algorithm that would automate that for them, so you didn't have to have somebody kind of paying loads of attention doing it, especially when those press conferences went on to midnight, which was annoying. And then I think this is the final one of a project that we're just starting where we're using audio to do automatic quality control. So if you've ever been into going to see a broadcaster, any broadcaster, say I was at NBC out in Connecticut a few months back, and I went into their master control room, the MCR. And if you go into any of these rooms, they're basically all the same. There's a billion TV monitors in front of you. It's totally overwhelming. And every single output from NBC is represented there, basically on one of the TVs. And there's people kind of watching, just checking for errors, and there's some diagnostics floating around. Silent, quieter than this room without me talking. Nobody says a word. And it just occurred to me that the silence means that no one's listening, right? So all of this stuff of 100 odd feeds that are going out, nobody's listening to. So you only know if there's a problem with the audio when somebody at home complains, and it's a very reactive setup, and not everybody complains. So you might not find out until it's too late. So we're using AI to understand when there are errors and to listen out for speech intelligibility metrics, for example, so you can make sure that you're delivering content that people can actually understand and hear the speech. So you're not waiting for them to complain before you turn up the fader. You can actually send a message to the mixer and say, it appears that you need to raise the level of the speaker in this particular broadcast or something like that, or phase errors or problems with microphones, EQ discrepancies. Maybe it doesn't match the house style that you want, or you've got a 5K hum or a buzz or something like that. So using AI to do that automatic quality control or detecting languages automatically is another one I think is a cool use case, and it could fit in either kind of at the truck, so that you could detect kind of problems on the live microphones, or it could be in the distribution end where you're listening out for encoding artifacts and speech intelligibility problems, and basically picking up errors before it gets to people's homes and before people get angry. And I might show this in a bit more detail in a minute, but this is the software tool that we've created. So all of these kind of concepts that we've thrown out, they exist. And this is our MIXAIR software that is a broadcast tool that's being used today to do all these things. So it can manage multiple output mixes, it can do panning, it can do MPEG-H, it can do Dolby Atmos, it can create automatic pitch mixes and do loudness controls, and it can run plugins and record and stuff. Lots of things. I'm happy to talk about that more offline. It can also be virtualized in the cloud, and I think that's a really important thing when we're looking at tools at the moment, is kind of how are we thinking about where the broadcast industry is going, because so many workflows are now fitting into the cloud, and therefore a few things that you need to think about is how you're getting the streams up to the cloud in the first place, whether you're using like 2110, SRT, RIST, or other kind of network protocols, and then when it's there, making those audio assets available and running the automated mixing, because if you're doing operations in the cloud, actually manually mixing becomes quite a challenge, because you've got to make production decisions that you don't get the audio feedback straight away anymore. So you raise your fader, then you've got to wait for that to go up to the cloud, and then for the audio to come back down to you. You go, oh, I think I just raised that fader too much. Like 5 seconds later, you pull it down again. Oh no, I pulled it down too much. You know, do you see what I mean? It's not quite as, don't get instant feedback like you do if you were just monitoring it locally. So there are some challenges to our cloud-based panacea of audio mixing, and that's where I think some automation really needs to be deployed if you're doing cloud-based mixing. So last slide, really, just to kind of highlight the fact that there are challenges associated with what I've been talking about. And I think number one is probably, when looking at AI, for me at least, is tagging the data, and it's creating these neural network models and kind of creating the right processes and optimizing everything, and basically making sure that you're using the right tool to do the right job, because it's not the case that you throw AI at absolutely everything and it suddenly improves everybody's lives. You need to use the right tool at the right time to do the right thing, and in some contexts, AI maybe isn't the right tool and is a bit over-engineered, or is just not what we really want. And you can't talk about AI by mentioning what about people's jobs. And so just put a question mark. I don't know. I haven't got the answer to that, and it's probably not my job to pose an answer to that, other than to say, in terms of where I sit, which is in live broadcast for sports, I spend half my life hearing people say there's a skill shortage, and half the time hearing that AI is taking everyone's jobs. So I'm not quite sure which one is the case. Are there any jobs to be taken or not? But the fact is, and I think the kind of the headline really is, there's plenty for people to do, and AI is not making people redundant in this respect, because actually the requirements are just going up and up and up, and budgets are going down. So I think it's a really important tool, and people are not going anywhere, so fear not. And that's why I put assistive versus automated, because actually the job of mixing a live show is so involved that we're a long way away from AI replacing people entirely for, say, like the World Cup final. People are going to be doing that for a lot of years to come. Maybe for, like, we automate mixing for some more niche sports, but it's assistive in that we'll do sort of 5 this is hockey out in the Nordics, ice hockey. Our engine mixes 5 games at once, and then there's one individual who QCs those, quality checks those as they go. So it's much more efficient, and it's an assistive tool. And then the other challenge, the final challenge for me, is there are just too many cool things to do, and I want to be able to do them all, but it takes a long time. So that's my biggest challenge. And with that, maybe we can have some questions and have a chat, if we've got time.
Well, thank you, Rob, for that fascinating journey. And for those watching online, I can confirm that the applause was real. We didn't use a neural network to work out how good the talk was and how long an applause to play in. So you've taken us on a really fascinating journey. And I don't think any of us are ever going to quite believe anything we see on television ever again, because we now know that the sound of the skiing is just somebody with a MIDI keyboard. Let's shatter that illusion. So, who has question? Who's going to be the first with a question? Okay. Hang on. So if you can please tell us your name and your affiliation.
Hello, my name is Ross Lipscomb. Yeah, my question is really about the machine learning, like overfitting, kind of underfitting. FIFA had recently mentioned that they were going to change the technology of footballs. And so you can imagine they change that technology and suddenly your model doesn't fit quite right. I just wondered, yeah, what your solution to that is?
Yeah, no, so that is a really good question. I think that is where you need diversity in the training data for sure, to kind of try and alleviate that problem. And so we've trained ours on kind of as many different sort of types of stadium as you could conceive of, right, ranging from kind of Livingston or like what's the smallest one, probably Guiseley, in the whatever league they're in, right up to the Bernabeu. So having that kind of complete diversity really helps. In terms of if they were to change the technology, it'd have to be quite a drastic change. There's certain, in terms of the football, I know tennis is a good example because they are actually changing they're talking about changing the tennis balls, how like pumped up they are, and that could cause some problems. With the football, the sound of a football has actually got quite a unique signature, which I think lends itself to machine learning. So that the sound of a sphere pulsating is actually quite unique, really. And so if they made the ball bigger, that might cause an issue. But I'm hopeful that won't happen. At the moment, the sound of that ball doing this is like a unique enough machine learning to be pretty robust at detecting. But I think certainly the volume of data definitely helps that overfit problem.
Okay, thank you. Next question. Yep.
Michael Prosser, IET member. Perhaps a slight follow-up to the previous question, but in honing the models, does that impede their sort of transportability? I mean, you mentioned about different stadia. Could you take the football model and use it at Twickenham?
Interestingly, almost. So we didn't do it with Twickenham. We did it with Aussie Rules, with a broadcaster out in Australia, and to some extent it works. But we had to reduce the sensitivity of the model so that we have to kind of like allow the classifier to play fast and loose with the neural network a little bit, because the ball is no longer a sphere. So any sport where the ball is a sphere is more likely to translate better than rugby, where the ball is no longer like that. But it does still, it would work to some extent. But so what we would probably do is do like a transfer learning approach, where you take a model that works, and then you say, take this model and now adapt it to work with this new data set. So like, it's kind of saying, they do it a lot in image processing, where you say, well, we know we've got this image processing task and we know it's good at recognizing a certain number of shapes or whatever. Now can you apply it to this very specific case of recognizing cats or something like that? So we would probably do that. Like, you've got your basic ball detector, now can you hone it to work for a rugby ball rather than a football? And that would reduce the number of instances that we would need in order to train it, because it's kind of got its background training already. If that makes sense.
Hi, I'm Alex Wegman, Bournemouth Uni, AES member. In your experience, do producers, is there a reluctance to put something to air that's not had a human say, yep, you can put that, you can lift that fader? Or is there kind of a new workflow? I mean, presumably there's loads of new workflows, but presumably there's risks of things going to air, or even just a caption that appears with a swear word in it or something, which has had to be, was not curated by a human. How is that being negotiated or navigated in terms of?
It's a great question. because I think that is just a sort of almost like a societal question. It's certainly a question that the whole broadcast industry needs to ask themselves, because we're going down a non-sustainable track, really. I mean, if you look at what is available to you as a customer on an OTT platform, you can basically watch anything, and there aren't enough people to mix all of that. And so there's already stuff that goes out without people really listening to it. So if you were to, there's a number of broadcasters who would show kind of every single game from a certain league, and they're relying on an individual mixing the graphics, the video, and the audio, all one individual. So they're not listening. They're doing the camera cuts, and they don't really. So what I'm trying to say is there's so much going out that it can't all be listened to, and so actually using AI at least is giving you a better chance of not sending out something. Yeah, but I think, to your point, I think there is a reluctance in terms of things that would be considered kind of like the blue ribbon events and the flagship products that these broadcasters spent like £10 million just on acquiring the rights for one game. You know, they're quite precious about that. You know, people are always going to be listening to the Super Bowl and watching the Super Bowl and producing it, and there's a huge teams that doing that. But for those more niche events, definitely I think people are coming to the realization that these are tools, not barriers. And actually, in the same way as like, no one's going to say, oh, I'm not using autofocus on my camera because it's AI, or like everybody loves autofocus because our photos look better. And so hopefully our audio content's going better, and I think given time there will be more confidence in it.
Time for one last question, anybody? Oh, yep.
Hi there, it's Paul Stallard from Meripar. You talked a bit about the possibility of using the audio sensors for detecting where the ball was on the pitch or where the referee was or whatever. Obviously, they also have the video processing that's doing player tracking and ball tracking. I just wondered if you thought there was any synergy between the two domains, maybe in which direction, whether the audio domain could help with the video tracking or the other way around. Yes,
without doubt. So there's a few things on that which I think are definitely add value. When we set out, we wanted to produce a technology that didn't have any additional requirements. So I wanted a software tool that was like, you don't have any additional microphones, you don't even have to have a video feed, you just have to have a computer that could receive audio signals, and that's the only requirement. So that's why we designed it to work just with audio. Obviously, if you're able to add data streams in, it increases and improves the performance. So you could take in the one of the camera angles, say camera 1, and then that could certainly tell you only need to listen to these 3 microphones. And if you're only listening to 3, then you can run a deeper neural network and you can make it even more accurate. So that, without doubt, would help. And I think the other thing that we've been talking about is there's a concept of audio follow video that's like massively used in broadcast, where you you cut to certain audio streams based on which video streams being cut to. So a classic example, when you have a steady cam down the touchline on a football pitch, when the producer goes to that camera feed, then they'll take the audio feed from the camera rather than from the pitch microphones. So, and that's all triggered automatically. So I like the idea of that there's audio follow video, but then maybe there's video follow audio as well, and you use the audio to make video decisions based on kind of audio regions of interest. One of the things that we, when we were out in Qatar, is we took the data from the ball. There was a sensor in the ball for the first time, and we got access to that data and used, so it's got an accelerometer, and a gyroscope and some kind of position tracking in it. And we use that data as, it's just the experimental project, it didn't go out on air, but we took the gyroscopic data to look at where the rotation state of the ball changed, and that was where it hits a transition, so that's where there's a bounce or a kick. And then we looked at the accelerometer data to figure out how big that event was, and then we triggered the sound of a kick that would match up with that kick event, so that you could just listen to the doosh, 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 and it was unbelievable. Like, it sounded so good. So that's I think is an example of kind of what you're saying, of where you use one data stream to augment the other. And so I think audio can add value to video, and I think video and other data tracking can add value to audio. So yes, but it's nice to be able to do it just with sound, I think, because, like I say, it doesn't put any additional requirements on anybody. And the tracking data, is worth saying, is very expensive. So although as viewers we get it for free, it costs the broadcaster a lot of money to process all of those stats or to sign up to the multi-camera tracking system. The companies make a lot of money off that data. So that's why I kind of feel like audio can add a lot of value, because we can get that data without requiring loads of complicated and expensive infrastructure, and microphones are cheap.
Okay, well, thank you very much indeed. I've got a few thank yous to say. I need to say thank you to the IET for supporting these events. I need to say thank you to Solent University for hosting us, providing such wonderful hospitality and lovely facilities, and to the crew they have provided to allow this event to be streamed. And of course, to Rob for a fascinating talk that really has lifted the lid on how things are done now and how they might be done in the future. So thank you very much indeed. Thank you. So do keep an eye on the IET website and on our YouTube channel, because this is just the first of a number of talks we have planned. So stay tuned, there'll be more along. Thank you very much indeed.
You're welcome. I don't.